Hello, our project title is Real Time Air Quality Monitoring System. Our team members include Rishita, Aparna, Sirisha, Chandupriya, and myself, Meghana. In today's cities, the issues of air pollution has emerged as a significant worry. Despite numerous technologies aimed at addressing this concern, none of them have proven highly effective. While current systems provide updates on present conditions, they lack the ability to predict air quality. In the light of this, our goal is to create a system capable of forecasting air quality. This system will not only offer real time updates but also empower people with advanced alerts, enabling proactive measures to tackle air quality issues.
Now coming to problem statement, to tackle the present issue of real-time air quality monitoring, a multifaceted approach is crucial. Firstly, expanding the scope of data monitoring through additional sensor deployment and advanced data collection methods will provide a more comprehensive understanding of air quality dynamics. Simultaneously, developing sophisticated algorithms capable of handling the complexity of various pollutants will enhance the accuracy and reliability of the monitoring system. Furthermore, addressing the challenge of result misinterpretation involves incorporating user-friendly interfaces, providing a clear contextual information, and ensuring effective communication channels for stakeholders. This integrated strategy aims not only to overcome the limitations but also to establish a robust framework for sustained and effective air quality management. Now, coming to existing methods, some of them existing methods in the context of air quality management would be the sampling techniques. These work basically on selecting a sample of data and derive varied conclusions from the data. There are different types of sampling methods based on the scenario given, but the sampling methods did not show a significant process in the air quality prediction, as it involves a lot of factors to be considered and make accurate predictions. These techniques have not been shown some significant results, and there is reasons due to inappropriate selection of sample data. A carefully throughout sampling plan guarantees that the machine learning model trained on the gathered data can reliably forecast air quality in a variety of scenarios and geographical areas. Now, my friend will continue.
While coming to the proposed method, we are using KNN algorithm, random forest classifier and decision tree classifier. In KNN, we train the data and predict it. Here we calculate the accuracy for the prediction and then we predict on test and calculate the accuracy metric. And then while coming to the random forest classifier, here we predict on test and get the accuracy metric values on the prediction of the test data. Here we find the Trappa store by combining the multiple decision trees and we will be getting the predictions. While coming to the decision tree classifier, here we split the factor and divide the data set into multiple categories. Here we classify into good, moderate, poor values. Next will be continued by my friend Aparna.
So here comes the implementation of the project. So we considered the data set which is in the specific year, which consists of many years, and also the factors which determine the air pollution quality or the air quality index. So these are all the columns which we have included in order to train the data set in the proper way. And along with that, we integrated the real-time aspects in the form of a Power BI dashboard. So Power BI dashboard is basically is used to actually create create the data set in such a way that we'll be able to modify and also will be able to display and view the data in real time scenario. Here is the short demo where this is the Power BI dashboard for the air quality index. So whatever the location, suppose whatever the state we choose, we can choose the state and we choose the corresponding location, and we choose some corresponding year and the month. So here we can observe that by choosing different location, year and month, we get the corresponding results for the air quality index in the form of different parameters. And these parameters somehow decide the quality of air in that particular location. Suppose if we deselect this and come back to the initial position of the dashboard, the changes are reflected correspondingly. So this is how we integrated the real-time aspects, where whenever we choose some location or year or month, correspondingly these changes are reflected, and when we deselect, correspondingly the deselection features are reflected. So this is how we worked on the real-time data, where it shows the results accordingly as the user views to choose to view. And coming to the code, so this is the Jupyter Lab network, where we use this platform to execute our findings. So starting with the dataset cleaning, we started off with collecting the dataset, then defining its shape, then cleaning the data to avoid some null values if they are present in dataset. Then we got a glimpse of dataset so that we get a clarity of what features are included within the dataset. Then we have the number of features accordingly, their count in the whole dataset. And this is where we got the columns description, where what columns have been included in that particular data set. And we have done a couple of visualizations on the data set in order to describe it and understand it in the right place. And these are some couple of visualizations. Here we can see the particular factor levels of different states, which is like the SO2 levels of different states. This is something for the count of states, like how many times there have been cases where the air quality index has been low or higher. And this way we have done a couple of visualizations. This is where we have done the data pre-processing, where we have transformed the data into a well-defined structure so that it can be used to predict the values and be integrated into the Power BI dashboard. So this is where we calculated the air quality index accordingly. And this one we classified based on the values which we got in this previous code results. We just classified the locations into different phases, like good, moderate, poor, unhealthy, and very healthy or hazardous, based on the index which they get upon training of the data. And we trained the data, we built a model where it actually shows the results of the air quality index and also predict how worse it can get or how better it can get. So these are the ML algorithms which we have used. This is the linear regression, and one of them, and other one is the decision tree, where we have trained the data accordingly, and the random forest, as we have discussed earlier in the slides. And these are the classification algorithms. This is the split factor which we have decided on the data set, and correspondingly we have performed a regression classification in which we have done the decision tree classifier and the random forest. And this is where the KNN has begun. So this way we have predicted the results and trained the code and built the Power BI dashboard accordingly. And this is the whole implementation of the project in a nutshell. And this would be concluded by my friend.
Hi, my name is Chandupriya, and coming to the conclusion, our project air quality prediction system is comprehensive and well articulated. The integration of KNN, random forest, and decision tree algorithms to enhance real-time air quality monitoring addresses a crucial need. Our focus on overcoming the limitation of existing methods to achieve more accurate predictions is noteworthy. Including implementation details, dataset descriptions, and algorithmic approaches provides a clear understanding of the system's workings. The incorporation of the Power BI dashboard enhances usability by adding real-time elements. Evaluating the system using accuracy and kappa score as performance matrices is a sound approach, demonstrating its potential as a valuable tool for informed air quality management decisions. Continuous improvement efforts promise to further enhance its effectiveness and reliability. Our project seems to be a significant step forward in environmental monitoring and management. Thank you.